Welcome to this session on subnational and imputation. My name is Filipa. I'm from King's College London, and we've got three papers in this session. On the line on the video we've got Bart from the University of Groningen. He's going to start the presentation, and the paper after is presented by Peter Levell from the Institute for Fiscal Studies. I cannot see him in the participant list yet, so I'm not sure whether he will be joining us or not. We will wait and see. And finally, I will be presenting my paper. So the way this is going to work is each presenter will have 20 minutes for the presentation, and then we have 10 minutes for Q&A. So if you would like to ask any questions, you can just type them on the Q&A. I will be taking a look at that as we go along. And then at the end of each presentation, we will be going over those questions and discussing them. The session is being recorded, so if later on you would like to watch it, it will be on the ESCoE website, on the ESCoE conference website. So let's just make a start. So I will hand over to Bart from the University of Groningen, and he's presenting the sterling depreciation in June 2016 and regional competitiveness in the UK.
Thank you very much, Filipa. I'm trying to share my screen. Hopefully that works out. I think so. Yeah, thank you very much for the opportunity to present at this conference in a slightly different setting than anticipated. Still, I'm happy that we can contribute from Groningen. And we, in this context, are Marcus Ketterer, who's a former graduate student of mine, and myself. And we are both working at the Groningen Growth and Development Center. And I'm also associated with ESCoE. So today, no, I should trouble in. Today I would like to talk about the one of the immediate consequences of the outcome of the Brexit referendum in June 2016, which relates to the depreciation of the pound as compared to other currencies of major trade partners like the euro area. So the pound lost close to 6% overnight. It lost about 8% to the US dollar and almost 11% to the yen, for example. And this led to discussions about potential positive consequences for the competitiveness of the United Kingdom. So in the Daily Express of January 2017, Donald Trump was quoted, and he indicated that this would have seriously positive effects on the UK economy. And much later on, Corbyn, the then Labour leader, indicated that the lack of increased competitiveness as observed on export markets was mainly due to the lack of an industrial plan by the Conservative government. And I would like to use a new method to shed some light on the implications of this depreciation of the pound on the competitiveness, not of the UK as a whole, but on different regions, because, as you know, there's a lot of discussion about regional inequality within the United Kingdom, especially between, let's say, the south, the region around London, and the rest of the country. Now, when we assess these consequences of on competitiveness, there are a few issues that we should take into account, especially if we look at regions. So if we focus on regions, we have to bear in mind that firms in regions in the UK not only compete on foreign markets, but also on domestic markets. So if we are assessing the competitiveness effects of this fall in the pound, we should take this into account. And this is mainly due to the fact that some firms in some regions depend much more on imports to produce their products, also sold elsewhere, than other regions. So this emergence of so-called global value chains, or sometimes value chains in regions, play a role, because it's not so much gross exports that tell you about the increased competitiveness for a regional economy. It's much more what the implications for value-added generation are. So our research question is, how different have the immediate price competitiveness effects of the referendum induced depreciation of the pound been across UK regions? In order to address this question, we use a novel type of exchange rates, the so-called value-added real effective exchange rates proposed by Bams and Johnson in a relatively recent paper in American economic journal Macroeconomics. And the data that we use, and I will tell more about that in a few minutes, is the Euregio Global Input-Output table for 2010. That's actually the most recent table that's available that can help us address questions like these. So what do these Euregio input-output tables look like? They are global input-output tables, quantifying in a sense the global economy, but then with interregional detail at the NUTS 2 level for EU countries. One of the downsides of these tables for many applications is that there are only 14 industries distinguished, so that's much lower level of detail than in let's say national input-output tables as produced by national statistical institutes. But for this specific application, this is not an issue, fortunately. So these Euregio data, these Euregio input-output tables, and we will only use the one for 2010, are based on several sources of data. First, the World Input-Output Database that was mainly constructed here in Groningen. Then we needed information from regional economic accounts, and these were taken from Eurostat. So ONS supplied Eurostat with these data, and we got additional detail based on data from Cambridge Econometrics. We used the regional supply and use tables if available, and for the UK this means that we explicitly included this type of information for Scotland. And then interregional trade in goods is mainly estimated using transportation data, correcting for the existence of so-called transportation hubs. And interregional trade in services is really hard to measure. International trade in services is already problematic sometimes, but at the regional level this is even worse. And the best type of data that we could use to estimate interregional flows is based on business class travel data. So let's now move to the brief discussion of exchange rates. So the most well-known exchange rate is a nominal exchange rate, bilateral. So that would be, for example, the number of euros per pound. If this decreases, the pound becomes cheaper, and this would imply an increase in competitiveness. Now, in reality, if you focus on countries, then countries trade with multiple partners at the same time, and quite often they have different currencies. So the so-called nominal effective exchange rate is obtained as a trade-weighted geometric mean of these bilateral nominal exchange rates. It is important to take into account that price levels are quite often different across countries, and one of the most well-known examples is reflected in the Big Mac index published by the Economist. So we should take a change in price levels into account when we focus on real effective exchange rates, and these often include consumer price indices in the weights. Now the big issue is how to determine these weights, and until recently this was mainly done using gross exports. So a country to which a lot of the exports are directed, they get relatively high weights, large weights, and countries that are less important in the exports basket, they get smaller weights. This has also been done, although only very rarely at the regional level. So in Journal of Regional Science in 1999, Clark et al. Studied competitiveness, and it should be stressed that this relates to price competitiveness for US regions. And much more recently, there was a paper in China and World Economy in which a similar analysis was done for Chinese provinces. And as far as I am aware, these are the only papers that address regional competitiveness using these real effective exchange rates. Now, if you focus on regions, it's also important to bear in mind that regions do not only compete at the international level. So if you look, for example, at firms in Cornwall, they also compete for market shares on markets in Devon, for example, whereas the depreciation of the pound, of course, didn't have any implications for the exchange rate between Cornwall and Devon. So this is something that should be taken into account. And then we really need these interregional input-output tables, which also inform you about the origin of products used in Cornwall and the destination of products produced in Cornwall. So if we look at the heterogeneity, the importance of international trade for regions, then we find that we could use as a measure the gross exports as a share of total regional sales. And then we find that for Greater London, for Northeast England, and for Northeast Scotland and for Eastern Scotland, these percentages are relatively low at about 12%. But for Hampshire and for Gloucestershire, for example, we find shares that are about twice as high, or close to twice as high, 21 and 23% respectively. So there's quite some heterogeneity in terms of the dependence of regional economies in the UK on exports to foreign countries. Now, the main contribution by the paper by Benz and Johnson is that we should not focus on gross exports, as I mentioned, but on value added. So we should also know the extent to which exports or products sold to other regions depend on products that are purchased in other regions or in other countries and are imported. So we should not only consider heterogeneity and the importance of exports to other countries, but we should also look at heterogeneity in the origin of products and on international imports. And then we see that again that there are differences. So for Eastern Scotland and for Southwestern Scotland, for example, the shares are very low. Only 4 or 5% is imported from other countries, whereas these shares are close to 12% for Hampshire, Gloucestershire, and Leicestershire, for example. So how do we define a value-added real effective exchange rate? Again, we do this following Benz and Johnson. So the change, the heads indicate log changes, and on the right-hand side we have a change in the price of value added in region I relative to value added in trade partner J, and this is corrected for changes in prices at the national level using data from OECD. And then we have the elasticities as weights, and it's important that in a world with global value chains, value added in country I and country J can be both substitutes, but they could also be complements. So if value added generation in the car manufacturing industry in a region in the UK depends on steel from, I don't know, from a German region, then it can be that these two regions are actually, the value added in these regions are actually complements rather than substitutes. And this is taken into account in the determination of these elasticities. The total elasticity is the sum of the weighted sum of three elasticities. So there can be substitution between final goods from regions. There can be, in principle, elasticity of substitution between the intermediate inputs from different regions or countries. And there could be a positive or a negative elasticity of substitution between intermediate inputs and value added. So between doing things yourself, producing intermediate inputs yourself, or sourcing them elsewhere. Now, in the most important part of our analysis, the part that I will show, we assume that rho and gamma, so the second and third elasticity, are equal to 0, which basically implies that we assume that the structural value chains cannot change. So we assume that there are contracts, that there are other reasons why the structural value change is sticky. So the effects of the depreciation of the pound are reflected in the competitiveness of final products. So the substitution between these can take place. So this is a rather short-term analysis, but we have shown in the paper that if we assume positive values for rho and gamma as well, that the numbers change a bit, but in a qualitative sense, in terms of the ranking of regions, we find very similar results. So what kind of weights do we find? Here I present some results for selected countries, for selected regions, and for example, on the right-hand side, you see that the weight of the rest of the UK can be quite variable. For Northern Ireland, it's only 43%, whereas for Highlands and Islands in Northern Scotland, it's more than 75%. What does this imply? These are the regions that gained most in price competitiveness as a consequence of the fall in the value of the pound. Gloucestershire, according to our analysis, was the main winner. But as you can see, the increase in price competitiveness was very limited, and this is mainly due to the fact that firms in Gloucestershire also sell to a large extent to other regions, much more than that they sell to other countries in the EU or elsewhere. Most of the main winners, other regions that benefited most in terms of price competitiveness, were mostly located in southern England. And the most important relative losers, so those regions that benefited only very little from the fall in the price of the pound, are mainly located in Scotland and in northern England. So here we have a graph between on the horizontal axis the trade weight of the United Kingdom, on the vertical axis the change in the value added real effective exchange rate. So those regions that are located at the bottom of the graph are those that gained most in competitiveness. So for example, Gloucestershire is located in the extreme left bottom corner. And you can see that there are a few outliers from the regression line. So in general, the higher the UK trade weight, the lower the benefits, which is understandable. But Hampshire and Gloucestershire are a bit off this regression line. And that's due to the fact that these two regions trade much more than other regions in the UK with the United States. And as we have seen at the very start of the presentation, the depreciation versus the dollar was much stronger than the depreciation versus the euro, for example. And that's why Hampshire and Gloucestershire benefited most. Then finally, and this is the last slide with results, we find that there is a slight increase of inequality in a sense, because we find that richer regions, those with relatively high GDP per capita, won more in competitiveness than those with low levels of GDP per capita at the regional level.
Bart, you have about 2 minutes left.
Yeah, so this is the, thank you very much. This is the slide with conclusions. So we find that the immediate fall of the pound after the Brexit referendum led to an increase in the price competitiveness of all UK regions, but to very low extents. And we also find that if we take all elasticities into account, allowing for changes in the structure of value chains. We also find that well, that's understandable. I think that the competitors of those regions that tend to export a lot to international markets gained more in terms of competitiveness than others. And we also find that those regions that are relatively rich have become a bit more competitive in general than the poor regions, which adds to regional inequality in the United Kingdom. Thank you very much.
Thank you very much, Bart. Now we will open the floor to questions.
Sorry, should I close my the slides or not?
No, not yet.
Oh,
you should
okay.
just stay there.
Okay, good.
If anyone would like to ask any questions, I'll just check. There are no open questions on the Q&A, but if anyone would like to ask any questions, just please type them in there.
So I would like to ask a question. I don't know if I can enter it in the Q&A as I'm one of the speakers.
Yes, please, Peter. Yeah.
So thanks, Bart. That was a really interesting presentation. So one of the points people have made is that because the role of value chains has increased over time, the effectiveness of exchange rate reductions in improving, for example, your external balance has diminished, and that's one of the reasons why the sterling depreciation didn't result in a big improvement in the UK current account balance. Mm-hmm. So I was wondering if your analysis could be used to examine over time whether that's the case for the UK.
Yes, well, in principle, I think that's possible. Although let's say the point of departure is always the current situation, and then let's say we assume basically in our analysis that the input-output table for 2010 was the input-output table for 2016. This type of interregional data is not available for more recent periods. Unfortunately, we would like to change that, but that's a different issue. But then you look at the current situation. You assume that there is a shock in the exchange rates, and consider the consequences of such a shock based on that current situation. Then you can make a distinction between long-run effects and short-run effects, depending on how high you set your elasticity. So if you assume that elasticities are very high in an absolute sense, then you assume that more adaptation can take place. And of course, that's always an assumption. Of course, for some industries, it's well known how easy it is to change the structural value chains, whereas it's can be much more problematic for other industries. But given that, but I think that in principle you could make a comparison between value-added exchange rates and more traditional gross exports-based exchange rates, and see which of the two comes closer to actual events later on. So you mentioned that the current account of the UK has not improved very much after the fall in the pound. it could well be, we didn't do this type of analysis, but it could well be that gross exports indicators, exchange rate changes would lead to much more positive implications than value added real effective exchange rates, because these take these imports into account.
So we've got a question here from Marianne Senzier. Could we unmute Marianne, please, so she can come on and ask the question herself? Marianne, could you please introduce yourself and ask your question to Bart?
Hi, can you hear me?
Yes, yeah, I can hear you.
Good.
Thanks.
Marianne from the University of Manchester here. Thank you very much for a really interesting talk, Bart. My question is, what policies would you recommend to help the competitiveness of the poorer regions, to help them with trading in the future in this kind of post-Brexit environment? Thank you.
That's a very, well, of course, thank you. It's a very important question, and it's also a very, very broad question. Yeah, my view, so this paper is about price competitiveness, but I think that in general, competitiveness of regions is much more dependent on, let's say, what you would call quality competitiveness. So what type of products are you selling as firms in a region? Are these let's say those types of products that are very traditional, for which there's a lot of competition, maybe also from abroad. So I think that as a region, you should try to be, let's say, ahead of the curve, trying to sell products, both goods and services, that are that are novel and for which there's a lot of demand. So it's possible to create a sizable markup over your production cost. And I think it's really important, especially nowadays, to work with others, because quite often innovation is a collaborative effort, for which several types of capabilities are needed. And yeah, well, I know this is a sensitive issue at the moment in the United Kingdom, of course, but my feeling is that you shouldn't try to do everything on yourself, but actively search for collaboration. And at the regional level, I think it's really important to focus on working with firms in other regions as well. So in my view, if you, for example, look at smart specialization policies, there's too much focus on the capabilities that are available within the region itself. Regions are often seen as, in these types of policies, as islands. Whereas I think that many regions would benefit very strongly by cooperating with other regions, sometimes neighboring regions, sometimes regions that might be a bit farther away, in which capabilities are present that are complementary to those that are present in the region itself already. And I don't know exactly about the British situation, but for example, in my country, in the Netherlands, I think there is still far too much focus on regions as isolated units rather than regions that are part of a network.
Thank you very much, Bart. I think we are pretty much on time for the second session, but if anyone would like to ask a very quick question, I don't see any more in the forum. So I think maybe we can move on.
Yeah, thank you. Also for the questions.
Do you mind stop sharing your screen? And we will turn now to Peter Levell from the Institute for Fiscal Studies, and he's going to present a paper on regression with an imputed dependent variable.
Okay, great. So, hello everyone. So I hope you can all see my slides. Okay, yes. So thanks very much for the organizers for putting together this program, and welcome to this session on subnational and imputation. I think it's fair to say that I'm here representing Team Imputation. So let's talk about regression with an imputed dependent variable. So the problem we're thinking about is suppose we want to estimate a very standard regression model, OLS regression model. We want to regress y on x, and we want to estimate beta, the coefficient. And suppose that the assumptions are met for, that would mean OLS would be fine if we had complete data for this problem. So x is uncorrelated with the error term, the rank condition is satisfied, and so on. But suppose we have a data set where we don't actually observe y. So for example, you might have some administrative data set that doesn't have the particular outcome you want to look at. You might be using survey data that has information on food spending, but doesn't have information on total spending. So what can you do in this sort of situation? So one way to overcome this problem is to use some proxy variable for y, or perhaps multiple proxy variables. And you can use them to impute the value of y and include that imputed value in the regression. And we're going to call those proxies Z. So in our setup, we've got two samples. Both of these samples contain Z. So we've got a sample that contains information on y and Z together, and another sample that contains information on x and Z. So we can use Z to impute y in the second sample, regress that in x, and use that to get an estimate of the value of beta. So in this paper, what we do is we spell out the assumptions you need to make those imputations, to use the proxy variables in that way. We talk about the right way to do those imputations. So in particular, some commonly used approaches lead to inconsistent estimates, and we'll show that. We show how to correct your standard errors for the fact you've done this imputation procedure. And then we illustrate the whole thing with a short empirical example looking at regressions of consumption on household wealth. So some examples of cases where this has been used. So a very common case is in the literature looking at consumption spending. A lot of surveys in both the UK and the US, they might ask about food spending, but they don't ask about total consumption spending. So you use food as a proxy for total consumption. And in another recent example, so some work Matthias presented at this conference on Wednesday, where we have census data. The census doesn't ask about earnings, but it does include information about people's occupations. So you can use occupations to proxy for earnings. So the relevance of all this work to ESCoE, so it's about making the most of existing data sources rather than throwing away data because it doesn't contain information on all the variables you want. We show how you can make the most of the data we have, for example, by combining survey and administrative data. The second point is that the correct imputation procedure, as we show, depends a lot on the context, on the question the researcher is trying to answer, the object of interest. And that means if you're including imputed variables in a data set, you need to think about how people might use them and how they might use them in appropriate or inappropriate ways. Okay, so this is some technical details about our setup. So we've got two samples, we're going to call them sample 1 and sample 2, and sample 1 we're going to denote with a subset I, and sample 2 with a subscript J. And all the observations are IID observations. They are drawn from the same population. The samples are independent of one another, and they have finite second modes. And then we have some fairly standard conditions on Z and X to ensure that you can take the inverse of those variables, and you can, in both samples, they converge to the same population value, and similar condition for Y. And these assumptions, they're sufficient to guarantee the existence of linear projections. So we could do Z on Y, where U and Y are by construction uncorrelated, just by the definition of linear projections, and a regression of Y on Z. And so what you can see immediately is you could use both of these imputation procedures to impute y. You could regress z on y, or you could regress y on z, and both of them will give you fitted values that you can use in a second stage regression on x. In terms of, we also make some assumptions that are needed for data combination, and these are quite standard. For example, in the literature on two-sample IV, you'd see very similar conditions. So as n1 goes to infinity, n2 will also go to infinity. We want to make sure that z is a good proxy for y. Gamma in the previous equation, in the previous slide, is not equal to 0. And x has to be uncorrelated with the imputation errors. So this is the sort of analogous to the exclusion restriction when you're doing IV. You don't want the errors in your imputation procedure to be correlated with your independent variable. Okay, so let's talk about some different ways that you could proceed in the context of this setup. So an early paper by Skinner suggested regressing y on z. You're using the resulting coefficients to take fitted values of y. In his case, z was food spending, y was total spending, and then regress these fitted values on x. So we're going to call this the regression prediction procedure, and it's been widely used in the literature, particularly on consumption. And if you like, you can add a first stage residual to get the variance right in the dependent variable. We're going to call that the RP plus procedure, regression procedure, prediction plus procedure. An alternative approach that was used by Blundell, Pistafari, Preston most notably, is to do the reverse regression of that. So regress z on y, take the inverse of the coefficient, and use that to get fitted values of gamma. And that's been used in a set of different papers. And although some papers use one method, some papers use the other, the justifications are often kind of ad hoc, and we're going to provide systematic justification for thinking about one method rather than the other. So a third method is to not impute y at a unit level at all, not at the level of individuals, but to recover beta from a combination of the moments taken from the two samples. So this was used in a paper by Arlano and McGeer, so we're going to call this the AM procedure. So in this one, you regress z on y, you get an estimate of gamma hat, you regress z on x, you'll get a combination of gamma and beta, gamma beta, and you can take the ratio of those two estimates to estimate beta. So one of the key results of our paper is that the regression prediction procedure, which is very commonly used, gives inconsistent estimates of beta. So unless you satisfy some quite unusual conditions, which I've written down there, so basically x and z are the same, or some other strange cases, you will get inconsistent estimates of beta using this approach. The intuition for this answer, obviously the formal proof is in the paper, but the intuition is, while if you have classical measurement error in a dependent variable, we know that doesn't cause bias. But when you impute the values of y, you introduce what's known as Bergson measurement error to the dependent variable. And those Bergson measurement errors, they're going to be correlated with the value of y, and that means in general they're going to be correlated with x as well, and that's going to induce a correlation between x and the error term, which will give you inconsistent estimates. And we can actually say more about the nature of that bias. So specifically, you'll get an attenuation bias. So the worse the fit of your regression of y on z, the greater the bias in beta. And in particular, it's directly proportional to the R squared of that first stage regression. So for example, in those cases where people were regressing food on total consumption, they were getting R squareds of between 50 and 17%. And that implies a downward bias in their coefficients of 30 to 50%. So the magnitude of these biases can be quite large. But fear not, because since this bias is an estimable quantity, we can estimate the R squared. It's something we can correct for. And to do this, what you can do is you can rescale the value of beta by the first stage R squared, and that will give you, as n tends to infinity, a consistent estimate of the value of beta in this case. And an easy way to do that is to just take the R squared from the first stage and use that to rescale the value of y, and then regress those rescaled values of y on x. You will get a consistent estimate of beta. So what about those other approaches we mentioned? So it turns out that in the case that there is a single proxy variable, so we only have one variable z, so for example in the case where we're using food spending, the value of beta hat using the Blundell, Preston, Pistafari approach and the rescale regression prediction approach and the Arellano-McGeer approach will give numerically identical answers, so they'll give the same answer. And in the case of the Blundell, Preston, Pistafari approach, that's sort of easy to see. They're running the reverse regression of y and z rather than z and y. And as we know, when you do the reverse regression, the change in the coefficient is proportional to the R squared. So you could use these approaches as well. The one key difference between these approaches and the rescaled regression prediction approach is that these ones will only give you the same answer with one proxy variable. The regression prediction approach, you can more flexibly include more proxy variables. So this is just to say, so if you're imputing, say, the mean value, or you're trying to get the variance of the imputed variable, different approaches will give you different answers. So in terms of getting consistent estimates of beta, all of these three approaches work. A regression prediction will give you a good consistent estimate of the mean in the sample, as will the RP plus procedure, but only the RP plus procedure will give you the correct variance. Okay, so just to talk about some simple practical concerns. So what if you have additional covariance? It's not just regression of y on x, you also want to include some control variables. So you can apply our results using the Frisch-Wall-Levell theorem, but in this case you have to remember when you rescale the y variable, you should be using the partial R squared from the first stage regression, partialing out those control variables rather than the R squared that Stater would give you. Okay, so a third contribution of our paper that I mentioned was we talked about how to get the correct standard errors when you use this approach. It's a two-step procedure, so you need to think about how that affects your standard errors. So relative to the case where you have complete data, there's no need to impute y. There'll be two losses of precision in the imputation approach. The first arises because you're using an estimated value of gamma, the first stage coefficient to impute y. And the second loss of precision arises because you're combining two data sets and there might be random differences between the first and the second samples. So without going into too much details of the algebra, this is the expression for how you should correct standard errors. And the key point to take away here is that the OLS standard errors will be too small. So if you just naively take your imputed variable and regress it on X, you will get standard errors that are too small. But you can correct those standard errors using sample analogs of the terms in the second term of that expression. And this standard error, it straightforwardly extends to allow for clustering and for heteroscedasticity. And we've created a Stater command for people to use this in your own applications. which is available from us and through a link in our paper. Okay, so let's now just illustrate some of these results with some empirical examples. So the case we're going to be thinking about is imputing consumption to the panel study of income dynamics, which is a survey in the United States. So this survey, prior to 1999, there were questions about food and a few other items. In 1999, they included some additional questions on other areas of consumption. And then from 2005 onwards, they included a much more full set of spending data and spending questions. So prior to, if you want to use the PSID 1999, you want to look at total consumption, you might have to impute it, as these other papers have done, using just the food spending. The sort of data source we're going to use to impute it is from the Consumer Expenditure Survey. And we're going to use the fact that from 2005 onwards, we have full spending data to consider cases where we've imputed the dependent variable, where we're using the data from the PSID, and where we're using our rescale regression prediction versus just a standard regression prediction. And we're gonna use this to regress consumption on house values for homeowners, just to sort of measure the effect of increases in housing wealth on consumption. And this follows a paper by Skinner in 1989, similar approach. And I said we're going to look at 3 cases using full data, using regression prediction, and using rescaled regression prediction procedure that we recommend. So starting off looking at the first stage, so we're imputing consumption spending using a combination of food spending, utility spending, and spending on cars. And we're looking at these for different years and for all years. And as you can see, the partial R squared in these regressions, it's quite stable. It's around 0.75. And that's going to lead to a bias in our estimates if we use just a simple regression prediction approach. So looking at the regression, so the first column shows you the effect of regressing consumption spending in the PSID from 2005 onwards on lagged income, current income, a lead of income, and current house value. And what you can see is that so each 10% increase in house value results in a 1% increase in total spending when you look at the PSID. When you impute total spending using the questions on food spending, which is what you would have had to have done prior to 1999 when the full set of questions were introduced, you get this downward bias in the coefficient. So you get a 0.8% increase rather than a 0.1% increase. And when you then adjust that whole procedure using our rescale regression prediction to adjust for this bias caused by the imputation approach, you get something much more close to the true answer when you actually use the full PSID data. So that's just a sort of illustration of the way our approach works and how it can correct the estimates you're using. So the key points I wanted to get across in this talk, using an imputed dependent variable can bias your regression coefficients. It does that by introducing a Bergson measurement error in the dependent variable, which causes a problem because those errors are correlated, are going to be correlated with your X variable. The magnitude of that bias is related to the first stage R squared, and it means you're going to get an attenuation bias, a coefficient bias towards 0 if you adopt the wrong imputation procedure. the method of the imputation approach matters. So it's not innocuous if you regress Y on Z or regress Z on Y, as different papers have done. And we saw that with the comparison of the regression prediction approach and the London Preston Vistafari approach. For data providers, for those providing survey data to users, possibly including imputed dependent variables, the key point we want to make is that there is no universally appropriate way of imputing these variables. So the best imputation strategy is going to be context dependent. It's going to depend on the particular regression people are going to want to run, and that's going to mean that you need to impute these variables with some amount of care. So actually, I'm now done with slides. So I'm happy to open up for questions if there are any.
That was perfect timekeeping, Peter. Thank you. So there are no questions at the moment in the Q&A panel, but we will wait a few minutes.
Okay, it looks like. So I'm happy to answer any questions people have, for example, by email afterwards if there are any.
Yeah.
But otherwise, happy to move on.
Okay, very good.
Okay, I'll stop sharing.
Excellent. Thank you. Bart, could I ask you, so I will present now, but can you tell me a couple of minutes before the end of my 20 minutes? Just remind me to wrap up.
Yeah, I'll happy to do so. So I was asked already by the host to take over the chair when you would present. So I'm happy to do so. So the next and final speaker in this session will be Filipa. She's working at King's College in London, where we would have had the conference if we wouldn't have had to move online. So as you can see, the title of her presentation is The Effect of Foreign Investment on the UK Housing Markets. Filipa, the floor is yours.
Thank you very much. So in this paper, I look at the effect of foreign investment on house prices using UK data. Okay, so this is a topical issue. The Mayor of London, Sadiq Khan, commissioned a report on this issue in 2017. And that report has been written by some researchers at the LSE. And in March 2020, the budget introduced a 2% stamp duty surcharge on non-resident buyers, with the revenue used to tackle rough sleeping. So if a non-resident buyer purchases a property in the UK, they have to pay the usual stamp duty tax plus a 2% surcharge. Okay, so there are other countries that have also looked at this issue and have introduced policies to control foreign investment in the housing market. So Australia, for example, encourages foreign investment in EU residential projects, but imposes tighter controls on the purchase of existing dwellings. So this is motivated by concerns that Chinese buyers were driving up prices in the Australian market. Switzerland as well has restrictions on purchases by non-residents. Vancouver and Toronto also have introduced a property tax on foreign home buyers. Israel also has higher tax rates for foreign home buyers, and Singapore has an additional stamp duty for foreign buyers. So other countries have also looked at this issue and have implemented policies to try to restrict or control foreign investment in the housing market. So when you look at the data and you plot foreign investment and house prices together, so I will tell you more about the data sources, but this is just a rough picture. So when you plot them together, you can see that they move, they move upwards together. So you see that there has been an increase in average house prices in the UK over time. And at the same time, you see an increase in foreign transactions. It's quite volatile, but it sort of trends upwards with house prices. So you see that they move together. Now you could try to come up with different explanations for this. So you might say that it's coming from the housing supply side. So you could say maybe what happens is there is a lack of land available for construction. Or you could look at the demand side. And I've done some research on this, looking at the effect of immigration on house prices. In this paper, I'm not looking at immigration, I'm looking at foreign investment. And there is a paper by Badariza and Ramodarai that is quite related to my paper, but looking only at London. There's also a macro literature on the effect of capital flows on house prices. So that's where the paper sits within the literature. Now, what I will do here, I will use data from the land registry on foreign investment. So the land registry has a data set that's called the Overseas Companies Ownership Data. And this data set was also released by the Private Eye magazine sometime before. They obtained the data through a Freedom of Information request and have actually developed a map on their website, which shows you the exact location of properties that are owned by foreign buyers. And you can see also in most cases how much they paid for the property. So I will be using that data to measure foreign investment in the housing market. And I will look at different outcome variables. So I'm going to look at the effect of foreign investment on average house prices and also at different points in the distribution of house prices. So I'm interested in seeing whether there's only an effect on the most expensive homes or whether you actually see a trickle-down effect to average homes and cheaper homes. I will also be looking at the effect on the housing stock, on vacant homes and on home ownership rates. So these are my outcome variables. So I've already showed you this correlation in the data, and these maps just show you the regional variation. So as you can see, there is significant regional variation, both on house prices and foreign transactions. So I'll show you also a table here. So you can see that most of foreign investment is actually located in London. So Westminster and Kensington and Chelsea have the largest share of foreign transactions. So this is a share. So the numerator is transactions registered to foreign buyers divided by total transactions times 100. So in Westminster, 27% of transactions in 2014 were registered to foreign buyers. Kensington and Chelsea have quite a high share, and then Greenwich, then you see Salford and Manchester, more Salford than Manchester. I will tell you, so Salford here, it's quite high, and I looked at this a bit more, and it has a lot of Chinese investment. And Salford is also where the BBC studios are located. So there is a lot of Chinese investment there in the data, and that's what explains this relatively large share of foreign transactions. And you also see a lot of regional variation on house prices. So, the highest house prices were in Kensington and Chelsea in 2014. That's still the case today. So over £1 million. Westminster also very high, and then, much lower in other local authorities. But, the point of this table is to show you that there is a lot of regional variation that we can use. So I will be using this regional variation to identify the effect of foreign investment on house prices from spatial correlations. Now, the identification challenge here is if I just run a regression of house prices, I get panel data, different local authorities, different years on house prices, and I get my panel data also on foreign transactions, and I run a regression of house prices on foreign transactions. The issue here is that you have endogeneity, right? So the direction of causality is unclear. So, you know, it can be that foreign buyers are buying in places where they think there will be higher appreciation. So, you know, you may have causality going from house price appreciation to foreign investment instead of the other way around. And foreign investors are not randomly allocated across geographic areas. So you have an endogeneity problem. So the way I deal with that in the paper is to use an instrument for foreign investment. I'll tell you a lot more about the instrument, but the instrument will be based on the idea that, you know, if there are political or economic shocks abroad, foreign investors may be more tempted to invest in the UK housing market as kind of a safe haven effect. And I will also be using the idea of home bias. So when foreign investors decide where they want to invest, they will choose areas where people from their country are already living. So I will preview the results in case I run out of time to cover all the different outcomes. So I find that there is a positive effect of foreign investment on house prices. And if there is a 1 percentage point increase in the share of foreign transactions, house prices increase between 0.7 and 1.8%. I also do a counterfactual where I keep the share of foreign investment constant at the level it had in year 2000. And I see that if foreign investment had been constant at the same, you know, the same shares it had in year 2000, average house prices in 2014 would have been between 16 and 28% lower. So, you know, they would have been between 162,000 and 190,000 pounds compared with an actual average of 215,000 pounds. I see that foreign investment has a larger effect on the price of expensive homes, so the top end of the market, but the effect is there at different percentiles of the house price distribution. And I also see how demand and supply interact. So I look at whether the effect of foreign investment is higher in places where housing supply is less elastic. And I find that indeed house prices increase by more in local authorities where the housing supply elasticity is smaller. There's no effect on housing construction. So, you know, there is a tendency to sometimes to argue that, well, foreign investment just leads to more housing construction. So it shouldn't necessarily increase house prices because it could just lead to an increase in the supply of housing. I don't find that in the data. So I don't find an effect on housing construction. I also do not find evidence of buy to live. So there's this idea that perhaps foreign investors buy the properties and then they leave them empty because they're just buying for investment and they don't necessarily use them. So they don't necessarily live there and they don't necessarily rent them out. So they could be just left empty and nobody is using these properties. In the data, I don't find much evidence of a buy to live effect. And I find that foreign investment reduces home ownership rates. So the data comes from the Land Registry Overseas Companies ownership data. It's based on 100,000 title records and it has information on tenure. So whether it's freehold or leasehold, it has the address. And in many cases, it also has the price paid. And it has the name and the country of incorporation of the legal owner and the date of registration. So from the date of registration, I'm able to build a panel data of, you know, having different years and, you know, the different shares of properties owned by foreign residents. So it's similar to data published before by the private eye. And for total transactions, I use data from the price paid data set from the Land Registry. This only contains residential properties. The overseas companies data set contains both residential and commercial properties. But because I want to calculate the share, so I want to divide the properties that are registered to overseas buyers divided by the total transactions, I basically removed the commercial companies, commercial properties from the overseas companies ownership data. So I will focus only on residential properties. The house price index is a repeated sales index and is from the Land Registry. So at the end, I have 172 local areas, local authorities, And the data goes from 1999 to 2014. And this is the model that I estimate. So it's a fixed effects model. And as you can see, is a spatial correlation. So I've got the change in the log of the house price index for local authority I and year T. And my key explanatory variable is going to be this share of transactions. So I have foreign transactions are going to be transactions registered to an overseas company divided by total transactions. And then I've got control variables. I have a lag dependent variable, and I have controls like unemployment rate and the share of local population claiming state benefits to control for the local economic conditions of these local authorities. They are introduced with 1 year lag, and I have year fixed effects and local authority fixed effects. Now, if I run this regression, I will have this endogeneity problem that I don't know the direction of causality. So, and the foreign investment is not randomly allocated, right? So foreign buyers are going to be taking into account the local conditions of local authorities when they decide where they are going to invest. So I'm going to use an instrument which is based on two ideas. One is this idea of safe haven. So if you have negative shocks, political or economic shocks abroad, foreign buyers will be more likely to invest in the UK as a kind of a safe haven. And then where in the UK are they going to invest? I say that they will invest in areas where more people from their home country are already living. So the idea that there is a home bias effect here. And this is plausible because, say, if Russian investors are investing in Kensington and Chelsea, they can find real estate agents that speak Russian and can help them, buy a property there. Or, they may even, if they are buying to let, they may prefer to buy in areas where other Russians are more likely to live, because then they can let the property to someone from their country. So that's sort of the idea behind the instrument. So for the instrument, what I do is I take a measure of economic and political conditions abroad, and I do different measures. So I use measures on government stability from the International Country Risk Guide, and also economic risk from the International Country Risk Guide. And I use an index of economic policy uncertainty from Baker, Bloom, and Davis. And I multiply this variable with the share of residents of country C in local authority I in a base year, which I take to be the 2001 census. And I sum this across foreign country C. So these instruments will be, used as an instrument for these shares here. So this is just telling you a bit more about the construction of the instrument. So the International Country Risk Guide, the economic risk index includes different measures like inflation, GDP, etc. The index of government stability is basically measuring what it says. So it's a measure of government stability, and higher values of the index indicate a more stable government. And the index of economic policy uncertainty is based on word searches. So it searches for words like uncertainty or uncertain, economic or economy, and then a set of policy terms. So for the US, for example, Congress, legislation, White House, regulation, Federal Reserve, and deficit. And it searches in newspapers, in newspaper articles, and higher values of the index indicate a higher degree of economic policy uncertainty.
Filipa,
So,
there are 5 minutes left.
Thank you very much, Bart.
Okay.
So the identification assumptions here are that the geographic distribution of the foreign-born population in 2001 is uncorrelated with recent changes in economic performance of local authorities, and that these economic and political conditions are exogenous to the conditions of UK local authorities. Now, I will just skip these details about the data, and I will go straight to the results. So you can see here, these are the results for house prices, and you can see that there's a positive and significant effect. It's bigger if I use the government stability index, and is smaller if I use the economic policy uncertainty index, and is somewhere in between for the economic risk index. The F stat, so the first stage F stat of excluded instruments is above 10 for the first instrument and the third instrument, and is a bit weaker for the economic risk index. So because these two are kind of an upper bound and a lower bound, these are the ones I'm going to be using in the next analysis. So, you can see here that there is this positive effect on house prices. Now, to get a better idea of the magnitude of the effect, I do a counterfactual where I keep foreign investment constant at the level it had in 2001. And you can see that average house prices, so this is what they are, the solid line is what they actually are in the data. And this is the counterfactual with instrument 1 and the counterfactual with instrument 3. So you can see, so the instrument 1 is this one and instrument 3 is this one. So you can see average house prices would have been a bit lower in 2014, especially if we use the first instrument. Now, I want to see if the effects are persistent. So for that, I use local projections. And so I can see the effects at different time horizons. And if I do that, you can see that the effects are actually quite persistent. So they are significant even 5 years after the shock. So if you think about an inflow of foreign capital, even 5 years after, you will see still an effect on house prices. And these here are regressions at different percentiles of the house price distribution. So you can see a bigger effect here at the top end of the market, but the effect is significant even at the lower percentiles. So it's not just affecting the most expensive homes, but is affecting other places in the distribution as well. So to see the interaction with housing supply, I use an index of the index of house price earnings elasticity. This is based on a paper published in the Economic Journal by Hilber and Vermeulen. And I use the house price earnings elasticity and I split local authorities by the median value of the house price earnings elasticity. So I split the sample into two. And you can see that, London, for example, all this region around London, and just the southeast in general is less elastic in terms of housing supply. So the house price earnings elasticity is related with the elasticity of housing supply. So I split the sample and I ran my regression for low elasticity and high elasticity regions. And you can see that the effect is actually coming from the high elasticity regions. So regions with a high house price earnings elasticity are regions with a low elasticity of housing supply. So if it's more difficult to build, you see that if there's an inflow of foreign capital, then house prices will increase by more. Yeah. So actually the effect on the low elasticity regions is not significant. So for housing construction, I don't find a significant effect, so I will not go into the details there. And for vacant homes, I used data from council tax returns on dwellings that are reported as being vacant. And I also do not find a significant effect. So it is not the case that in local areas with a higher share of foreign transactions, you see more homes being left vacant. I don't find an effect. I don't find evidence for that. And I use data from the census to do the same thing. And I also do not find a significant effect. Now with census data, I've also looked at home ownership rates. So I looked at the share of households in owner-occupied accommodation. And here I do find a significant effect. So I find that in local authorities with a higher share of foreign transactions, there is a smaller share of households in owner-occupied accommodation. So just to conclude, I see that foreign investment increases house prices, particularly for more expensive homes, but also at lower percentiles of the house price distribution. And I see that this effect is stronger in areas where housing supply is more constrained. There's no significant effect on the construction of new housing or homes being left vacant, but there is a significant and negative effect on home ownership. So I've concluded and I'll turn to the questions now.
Okay, thank you very much, Filipa. I see that there is a question already by Tony. So Tony, could you be so kind to switch on? Oh, Tony even has two questions. So maybe he can ask both questions after switching on his microphone. Tony, if you want to, you can go ahead. Well, otherwise I will first read his first question. So Tony's first question is, you mentioned that there is no evidence of foreign ownership affecting construction. Is this definitely true for apartments in London? Question mark.
So I have not separated the sample for apartments and houses. So, you know, I wouldn't be able to say, and I have not looked at London separately. So it's just for the total sample. So let me put up those results. So here you see the effect on housing construction. So the dependent variable is the change in the log of the dwelling stock. And, you know, I ran the regression on the share of foreign transactions and nothing comes significant, you know, on the OLS or the IV. So, but I don't know, you know, it could be that in London and for flats, you would see a stronger effect than for the rest of the sample, but I haven't done the separation.
Thank you, I understand. Thank you very much. Sorry, I was unmuted before. My second question was, you mentioned, sorry, actually, could you, the host read it out again, please?
Can we say Monday at 10:30?
I cannot see the question panel. So, Bart, would you mind reading out Tony's question, please?
Yeah, I somehow was also muted, but now I can talk again and hopefully you can hear me. So Tony, oh.
Yes, I can hear you.
Yeah, so Tony's second question is, have you investigated any correlation between foreign investment in commercial property or business and investment in housing? Question mark.
Tony, that's a very good question and is a good topic of research. I haven't done anything on commercial property, so this paper is just on residential. But the overseas companies data has commercial properties. So let me just, yeah, so this data set here has commercial and residential properties. Now, the reason why I basically threw away the commercial properties is because I wanted to scale things by total transactions, and the price paid data set only has residential properties. So I ended up just focusing on residential properties for the paper, but it would be interesting to see what happens in the commercial market. And the land registry, the overseas companies data set does have that information. I haven't looked, but there may be a different source where you can get the total transactions on commercial properties. But you know, so you could almost like redo the analysis just for commercial properties. If you had something to scale it by, it wouldn't come from the price paid data set because that's only residential. But I believe, I'm not sure, you know, but I think the land registry may have other sources on commercial property. I would have to look at that.
Okay, Tony is in a shared location with a lot of noise, so he would like me to thank you on his behalf for the answers to his questions.
Thank you for the questions.
Okay, are there any other questions? Currently, there are no open. Yeah, Marianne Saint-Jay has a question. So if you can unmute yourself, go ahead, Marianne. Hopefully that works.
I can actually see the question now.
Yeah, but Marianne is going to talk, I think.
Yeah.
Hi, it's me again. Thank you for very interesting presentations. So I'm just wondering, would you recommend an increase in stamp duty in these areas which have the greatest foreign investment?
Thank you, Marianne, for the question. I think it would make sense to have, you know, because there is a lot of regional variation, it would make sense to have regional differentiation in the policy. But, you know, the government, what the government decided was to do a 2% surcharge across the board. And I think that's simpler. And so, you know, it basically, it will hit more areas with more foreign investment than other areas. You know, so basically it has been implemented across the board. And I think that's a simpler policy to apply. And the idea is the revenue will be used to tackle rough sleeping. So I think the policy makes a lot of sense. Certainly, you know, my findings kind of support that. And the level of the surcharge is in line with what has been done in other countries.
Thank you very much. Are there any other questions someone would like to ask? No open questions at the moment. Anyone? There's a question by Dan Taylor.
Yeah, I'll go.
Oh, you can see it, Filipa.
EIV. I don't know if it's this one.
Maybe Dan can.
Yeah.
Oh, Dan, thanks you. Would you like to ask a question then? Apparently not. Oh, yeah. Then thanks you for showing the slide again.
Yeah, I think they will be posted and on the ESCoE website, I believe.
Yeah.
Yeah.
Okay. Would you like to conclude the session, Filipa?
Yes, thank you very much. Thank you to Bart, thank you to Peter, and thank you to all the participants for your questions. I believe there is a conference chat room where we can go and talk a bit more. Or if, you know, if the participants have any other questions, you can always get in touch with us directly. Thank you very much, everyone. Thank you. Bye-bye. Bye.
Bye.